My only hope is that by the end of this lesson, you know how to do it differentiation. No more confusion. Now, differentiation, there's a set of rules on how to do it differentiation. There's the product rule, there's the quotient rule, there's the power rule, as well as the chain rule. Okay? Ungakwazi uku differentiate using these rules, but if you don't know how to differentiate functions, it's pointless. It's very pointless. It's very, very pointless. So the purpose of this lesson is just to show you how to differentiate functions. So we're gonna go through each and every function, and I'm gonna show you how to differentiate them. Right? I'm sure no sines, no logarithmic, exponential, the tan, the sine, and expressions as well, where we apply the power rule. Okay. Now, let's start our conversation. Differentiation rules. Let's start with the rules for functions as individual, right? The individual functions. I'm going to show you how to differentiate each and every function. Let's begin our conversation. The derivative of a constant. Now, d of k with respect to x. So this is a symbol, as E7 for saying differentiate, right? So once you wanna this thing, just know that we're gonna be differentiating. So I have d of k, dk of dx. So we are differentiating with respect to x. So if you take the derivative of k, you're gonna get to bani 0. This basically says if you have a constant, the derivative of that constant, it's gonna be 0. As an example, we have something like y equal to 2. So the derivative for this, dy with respect to x, is equal to 0. Now, I wanna differentiate this function. There is no x on the right hand side, so it's just 2. So me differentiating with respect to x, I'm obviously gonna get to bani 0. So this is a derivative for iloganji, a constant. Maybe if we have something like this as well, just another example, we have pi squared. Basing it, we find the derivative with respect to x, dy over dx. Finding the derivative of this function with respect to x, it's obviously going to be 0. There's no x on the right hand side. Another example, y is equal to, say, maybe a squared. Still no x. The derivative of this function is obviously going to be 0. Alright, so that's the derivative of a constant. Let's take another one. You now have x raised to exponent n. Differentiating with respect to x would give you something like this. This is what we refer to as the power rule. This is the power rule. Okay. Now let's take our examples. So let's say maybe we have a function that is y equal to, I don't know, maybe x squared dy with respect to x. This is gonna be 2x. Another example would look something like 2x minus 1. Finding the derivative would be this minus 1 times out 2, it gives us minus 2. X minus 1. So from the exponent, you're going to subtract 1. We're going to have minus 2. Right? This is the power rule. Maybe one more example. Y is equal to 3 over x. Okay? So I cannot differentiate while x is a denominator in this case. So what I would have to do, I would have to rewrite this expression as 3x raised to exponent minus 1 dy over dx. Now I can differentiate again. This 1 will multiply that 3. Sneakers minus 3x raised to exponent minus 2. So from the 1, I'm going to subtract 1. this is what I have. Okay, this is my derivative. This is the power rule. This is the power rule. Okay, next up we have something that looks somewhat like this. Okay, so in this case, it's still the power rule in a way. It's still the power rule, but I want you to take note of the following differences. This one has an exponent. It can be minus 1, minus 2, minus 3, 5, 6, 17, whatever, right? But this one, uenla, or the exponent of the x, is just 1, right? It's just 1. Or we can simply say you have x, right? You simply just have x. So the derivative of x, or x raised to exponent 1, it's going to be the following. So uno ax, the derivative of ax, kufana nokuthi uvele wa drop x wasala no a. So maybe let's have several examples. That y is equal to, say, maybe x dy over dx. The derivative of this function y equal to x is gonna be just 1. There's a coefficient of 1, or x is raised to exponent 1. You just drop the x, salabani, the coefficient of that x. Another example would look something like so. Say maybe 2x dy over dx. This is equal to bani, just 2. You drop the x. Another example can look something like so. Maybe ax, why not? Y dy over dx. This is gonna be simply a. Alright, so this is how we treat this type of expression. Okay, so next example, next rule of derivative, another function is gonna be the exponential one. So we know that the derivative of an exponential doesn't change. So e raised to exponent x is just gonna be e raised to exponent x. E raised to exponent x. Next one, we have the log function. So the derivative of a log function is just 1 over x. Or ln x. The derivative of ln x is just simply 1 over x. Another function is the cosine function. When taking the derivative of a cosine function, you get to bani a minus sine x. Last one, no, not the last one, but if you take the derivative of sine x, you're gonna get bani cos x. Last one, the derivative of a tan x gives us what? A sec squared x. Alright, so these are the basic rules of differentiating functions, right? So we are dealing with these functions, only these ones: sine, tan, cos, log, the exponential, and expressions, or the power rule, right? Or the power rule. Now, let's take it up a notch again, man. Let's take it up a notch. Now, this is not always the case, Oguti. You're only gonna get a function as is. There will be cases where uthola a function within another function, or a function of a function. Instead of just having abu x, instead of just having x, wait, let me just highlight abu x on the right hand side. Instead of just having x, right? Instead of just having our x values only, you now have functions within the function. So say maybe for this exponential is a function itself, but utoguti, in the place of x you have another function. The function might look something like 5x, or x squared, or x squared plus 3, something like that, right? Now you know that I have a function within the function. Now, let's talk about the rules for function of functions. Number one. Let me just create a slide where I'm gonna write. Alright, number one. Now, usakhumbula, I think it was here. Yeah, it was here. Where we had an example of y equal to 2x squared. I think we did, man. No, not 2x squared, but it was x squared, just x squared, right? Basically, if we were to differentiate this, we're gonna have dy over dx. This is gonna be equal to 2x, right? 2x. Now, this is a similar case to this, right? But instead of just having x, you now have a function in the place of x. Let me show you what I mean. Here's an example. You know y, or a function that is equal to maybe something like x plus 1 raised to exponent, say, 2. Yeah, but these functions are the same. Okay, not the same, but almost similar. Let me say that. Now y, the x, instead of in the place of x, x plus 1. Ne? X plus 1. This is a function. This as a whole is a function. But within that function, there's also another function. It's the x plus 1. Alright. So lama functions, how do we differentiate them? How do we differentiate them? So differentiate. So rules for function of functions. We take the exponent, we multiply the coefficient in front of that function. Then we take away 1, and then whatever function is inside the function, we differentiate as well, right? So I think it would be a good idea if we beg out Tula, so that I can make the point I want to make regarding this function. So if I were to differentiate this, I was gonna say dy over dx is gonna be, I'm gonna differentiate this function as a whole first. So the 2 multiplies in front about 2 la. Then exala at 2x plus 1. 2 minus 1, xalu 1. Then I'm taking the inside function, this one, I'm differentiating it. So if I were to differentiate the function inside the bracket, it's gonna be just simply 2, and I'm gonna multiply with it. So this is similar to this, and then the 2 came out of finding the derivative of the function inside. Now let's simplify this thing further again. This is gonna be, this 2 times this 2 gives us 4. So the final answer is gonna be 4 in bracket 2x plus 1, like this, raised to exponent 1. This is the final answer. Okay, this is the final answer. Another example would look something like so. Let's say mhlambe we have y that is equal to 2, maybe x squared plus 1 raised to exponent minus 1. Okay, raised to exponent minus 1. So the derivative for this would look something like dy over dx. So this is a function as a whole, right? I'm going to take the minus 1 times that 2 as a total minus 2 in bracket give out x squared plus 1. Then I take whatever is inside the bracket, differentiate and multiply the original function. So the x squared plus 1, the derivative is simply 2x. So this multiplied by that gives us a minus 4x in bracket about x squared. Look, let me go back. Just kancane. So we took this minus 1, so multiply that 2, so total minus 2. So the minus 1 subtract 1 gives us a minus 2. Take whatever is inside the bracket, then differentiate. X squared plus 1, the derivative of x squared plus 1 is 2x. then the 2x multiplies that, it gives us a minus 4x in bracket, it's x squared plus 1 raised to exponent minus 2. So make it a habit with your final answers, you leave them as positive exponents or with positive exponents. So it's just going to be the minus 4x, then whatever that has a negative exponent, you write it as a denominator. So this is going to be an x squared plus 1 raised to exponent 2, positive exponent 2. Now, next function of a function. I think we had an example that looks something like this, right? But let me just make one more example. We had an example, the last one we did, it's actually a form of this type. So we have y that is equal to, say, maybe 3x, I don't know, maybe x squared raised to exponent minus 2, right? So a, now the f of x, it's the x squared, and then n, it's that minus 2. All right, so we multiply again, finding the derivative with respect to x. This minus 2 times that 3, it's minus 6 in bracket kuba x squared. This doesn't change, right? And then from this minus 2, we're gonna subtract minus 1. We're gonna subtract 1. So minus 2 minus 1, that's minus 3, multiplied by the derivative of this function inside. It's bunny. It's gonna be 2x. So this times that gives me a minus 12x in bracket kuba x squared exponent minus 3. So we write our negative exponents where to, or we change the negative exponents to positive exponents. So it's going to be a minus 12x over x squared raised to exponent positive 3. Shiela, right? See shiela. Next function. Now we have this e, the exponential function, the derivative with respect to x of the exponential function raised to exponent f of x. Example, you have something like, let's say y equal to e raised to exponent minus x. Now check out the difference. This is raised to exponent x, so now it differentiator, it just becomes e raised to exponent x. E raised to exponent x. You now have a negative x. Now we'll have to treat the negative x as f of x, right? As f of x. We'll have to treat that as f of x. Now to get the derivative for this, so dy over dx is equal to, what is the derivative of the exponential function? It's just e raised to exponent minus x multiplied by the derivative of this. What is the derivative of minus x? It's just minus 1. We multiply Sitolu minus e raised to exponent minus x. This is the final answer again. This is the final answer. Maybe we can have another function or f of x that is equal to, say, maybe e raised to exponent cubed. Then f prime of x, the derivative for this function is going to be, what is the derivative for this whole function? It's just e raised to exponent x to exponent 3 multiplied by the derivative of f of x. It's going to be what? 3x squared. Now simplifying this would give us 3x squared multiplied by e raised to exponent x raised to exponent 3. This is the final answer again. Now, next function, we have ln, or the logarithmic function. The derivative for the logarithmic function is 1 over this function multiplied by the derivative of this function inside the log function. Now we have the following, maybe as an example, say maybe g of x is equal to ln 5x squared, right? Oh, now singayibona, bheka. This is the ln function. So this ln is a function on its own, but inside the ln, instead of having x, uno 5x squared, which means that the 5x squared is another function within the ln function. To get the derivative, we would have to apply the rules of a function of function. So this is going to be 1 over 5x squared multiplied by the derivative of 5x squared. So this is going to be 10x raised to exponent 1. Simplifying this, it's 1 times this, it's 10x raised to exponent 1 over 5x squared equal to, then u5 ungena kayingaki ku10 ungena kayi2, so kusala u2, lo x oyi1 ukhansela u-x oyi1 ngapha ku-x squared, so kusala 2 over x. This is the final answer. Yes. All right, we cancel this. Let's discuss the next function. This is the next function. Finding the derivative of this function, and within this function there's also another function, right? Now let me pause kancane la and say ukuthi we are low key, sort of like low key discussing a chain rule under this discussion. We are low key discussing a chain rule. We are discussing the chain rule. Check out the description box for a full lesson, a full detailed lesson on the chain rule. Check it out. Now let's continue our discussion. Go back here. Imeza, okay. All right. Now then we continue. Let's have an example for these type of functions of a function. So maybe say, sine of 3x, and then y is equal to sine of 3x. So the derivative of this dy over dx is gonna be the derivative of this. I know what it's cos x. It's cos x multiplied by the derivative of the function inside the sine, that is 3x. The derivative of 3x is just 3, equal to 3 cos x. That's it. Another example would look something like y is equal to sine of x squared. So dy over dx, this is equal to derivative of sine x squared. It's cos x squared multiplied by, then you take this, you differentiate to tola a 2x. So simplified, it's 2x cos x squared. This is our answer again. Next function for this one, we're gonna say y equal to cos 2x, right? Finding the derivative for this would be dy over dx equal to minus sine 2x multiplied by the derivative of the function 2x. It gives us a 2. Simplifying this would be minus 2 sine 2x. That's it. Last one. I don't know. Give me an example. Y is equal to tan 2x. Dy over dx. This is equal to sec squared 2x multiplied by the derivative of the function within that function. So it's going to be 2. Answer, it's 2 sec squared 2x. Now I answer you too. So this this is very, very, very crucial before we even start talking about the chain rule, even start talking about double product rule and the quotient rule. Okay, so it's what? It's the learning how to differentiate our functions of functions and the functions themselves. Yeah? Now, let me clear the board and citate maybe several examples from a question paper and close off the lesson. All right, now I'm clearing everything except for this part. Okay, except for this part. So here's a question, a typical question from a question paper. Yeah? Typical question from a question paper. Now, before we answer this question, let me say the following. Before you differentiate, make sure you simplify first through BODMAS. Simplify through BODMAS. Now BODMAS. Simplify through BODMAS. We know that the B stands for bracket. The O stands for order or off. So B, it's brackets, order or off, it's our roots or rational exponents, third root. We know we simplify this to O half, exponent half. We simplify this to an exponent 1/3, so on and so forth. Then Sibano division or divide. The divide simply means that when x is a denominator, right? And then m multiplication, a addition, s subtraction. Okay, so BODMAS simply says start by solving a bracket, landing your order, divide, what the multiplication, addition, and subtraction. Okay, now we are presented with an example, 3.2.1. For instance, y is equal to 2x cubed plus 6 ln x plus x over 2 plus 3 e raised to exponent 4 plus 8x. Do you see how many marks it this one carries? 3 marks, right? So now I think what you have to ask yourself, Uguti, am I dealing with a function itself, or am I dealing with a function of functions? Now I have 1, 2, 3, 4, 5 terms, right? I have 5 terms. This is simply a function. This is also simply a function. This is simply a function. This is a function. This is also a function, not a function of a function. Now, how do we differentiate this thing? So, before we differentiate, let's ask ourselves, another thing that you should ask yourself, are there brackets? Of course not. Is there order? No. Is there division where x is a denominator? Of course not. Is there multiplication? No. There's only plus and subtraction. So this is a signal you can now differentiate. The 3 times the 2, 6x squared plus 6. This I'm gonna differentiate. So this is a function of a log, right? There's no function of a function. So this is simply gonna be a 1 over x multiplied by, plus, so a derivative of this would be just 1 over 2, right? 1 over 2. You have exponent x, you have x, just simply x. You just drop the x, ushi coefficient, as I've explained, right? Plus, this is a constant. Aguna x for the 4th term. There is no x la, and I'm differentiating with respect to bani to x. So there's no x la. So it means this whole thing, yonke, so it's what? It's a constant. Plus, ngapha I'm gonna drop the x, just simply drop the x. Now when simplified, it's gonna be a 6x squared plus 6 over x plus 1 over 2 plus 0 plus 8. This is our final answer. Right. Now with 3.2.2, we have y that is equal to the third root of x plus 3 sine x 5x minus 2 over the square root of 4x cubed plus 2e raised to exponent 5x. Okay, how many terms? 1, 2, 3, then 4 terms. Now, do I have function of a function? Yes, there's one. There's also another one. There's also another one, right? There's also another one. There's also another one, right? So we have functions within functions. Now, before we can even differentiate, I need to simplify through BODMAS. In my order, right? I have square roots. I'll have to simplify for this first, and okay, let's simplify for my roots, then I'll explain the next step. So I'll give about x raised to exponent 1 over 3 plus 3 sine 5x. Lana, there's nothing to simplify. Minus 2 over 4x cubed raised to exponent 1 over 2 plus 2e raised to exponent 5x. We simplify again. The x is a denominator. The x is a denominator. The x is a denominator. So I have to do what again? I'll have to susa the denominator and make the exponent a negative. So I'm gonna do the following. I'm gonna say x 1 over 3 plus 3 sine 5x as differentiate yet, minus 2 4x raised to exponent 3 raised to exponent minus half. Okay, you know what, let's continue. It's fine. I'm seeing a small error, but I'll deal with it later. Alright, now everything is in order. Okay, I can now go ahead and differentiate. So it's gonna be a dy over dx equal to, we multiply about 1 over 3x raised to 1 over 3 minus 1 over 3 keep a 1 sisala minus 2 over 3 plus, what is the derivative of this? The derivative of sine is just cos, so it's going to be a 3 cos 5x multiplied by 5, because we are differentiating this is nigeza cos 5x, then we have differentiated that function inside that function is nigeza 5 minus this multiplies that out, minus 2 multiplied by a minus half, it gives us a plus 1. Then go about 4x x raised to exponent 3 minus half minus 1, that's minus 3 over 2, but let me double check. Yeah, plus the derivative of this, it's what? It's just 2e 5x multiplied by 5 equal to okay, equal to. We are done differentiating. All we have to do is leave our answers with positive exponents and insert form. Use differentiation rules to determine the derivatives of the following, leaving the answers with positive exponents and insert form where applicable. If the exponent is a fraction, it means that thing you have to change into a surd. So simplifying this would be 1, it's going to be 1 over 3 raised to exponent x 2 over 3. Right? So we change this thing ibe a surd. So this is going to be equal to, okay, plus 3 times 5, that's 15 cos 5x, plus this has a negative exponent, so you balance 1 over 4x cubed raised to exponent 3 over 2, plus this times this, that's 10 e raised to exponent 5x. So let's write down our answers with positive with our surds again. Now we're gonna have continuing this. This is gonna be 1 over 3 cubed root x squared plus 15 cos 5x plus 1 over the square root of 4x. So 4x raised to exponent 3 plus 10e to exponent 5x. Alright, to exponent 5x. Ungayishiya so, or continue simplifying for this bracket, then we are again. Alright, then we are again. Alright, I'm gonna hide this and perhaps even stop the lesson. Should I? Or we have to simplify this one. Okay, let's take it. 3x squared plus 5x plus 2. You have a situation like this. What do you do? I don't have a bracket, right? I don't have the order, but I do have a division problem. Why? X is a denominator. So what do? We gonna take this x, divide each and every term on the numerator, right? Now you have 3 terms on the numerator divided by 1 term. Uthatha that 1 term about dividing ngayo, would divide each and every one on the numerator ngayo. So you're about 3x squared over x squared plus 5x over x squared plus 2 over x squared. Then we simplify further. This divides that salu 3. X lo x lo yo cancel x 1 ngapha salu 5 over x plus 2 over x squared. Alright, still there's a problem. X is still a denominator. Now what do? 5x minus 1 plus a 2x minus 2. Then we differentiate together. Dy over dx is equal to, this is a constant, it's 0. Negative 1 times 5, that's negative 5x minus 2. This times that, it's minus 4x raised to exponent minus 3. Oh, we have to leave our answers with positive exponents. So about 0 minus 5 over x squared. So we sell up hands. Once we sell up hands, it becomes a positive exponent. It has a positive exponent now. Then about 4 raised to exponent 3. This is the final answer. I'm gonna end discussion here to on differentiation, the differentiation rules. In the description box, I'm gonna leave links for the quotient, the chain rule, and the product rule, rules of differentiation. So for now, guys, I'm signing out. I'll spawn on the next recording. Peace.